God damn it. No. You're recording. You are recording this meeting. Be sure to let everyone know. Yeah, okay, I'm recording, everyone. I don't know what I'm recording, though. I think it does. I've done them before. I'm pretty sure it records my screen. If it doesn't, I'm going to have to make a video later, which will be a total waste of my time, but whatever. Okay, so we are recording now. So I started this question before I remembered to record. So basically I broke this down. Square root 9, square root x squared, square root y. Square root of 9 is 3. The square root of x squared is x. Now, can we simplify square root y? What do you think? No. It's the same kind of principles as before, right? So x squared can simplify because the square root of x squared is just x. But y would need to be to at least the power of 2 for it to be simplified. So that is just going to stay a square root y. So that whole thing simplifies to 3x square root y. Now the next one's actually going to make it a little bit easier to explain sort of how this works. So I'm still going to break it down by step a little bit. So square root 25, square root x to the power of 5, and square root y cubed. So basically what you want to do with your variables is you want to use the index number to help you. Now, when you guys learned division in middle school, did they teach you about remainders? I don't think they teach it that way anymore, right? So like if it was, I don't know, 9 over 2. Well, 8 divides by 2, and then you have a 1 as a remainder. Did they teach you about that?
No.
No? God damn. Well, kind of. So like back when I was in school, before they taught us improper fractions, they taught us about remainders because that helps you change an improper fraction into a mixed fraction. So basically when you're changing an improper fraction into a mixed fraction, you're working with remainders. So when you change this into a mixed fraction, we basically say 9 over 2 is the same thing as 8 over 2 and 1 over 2, right? So where 8, we use 8 because we know 8 is divisible by 2. 8 is the closest number to 9 that is divisible by 2, right? So we know we can divide that out evenly to get 4, and we pick 8 because, like I said, it is the closest number to 9 that is divisible by 2, but it leaves me with a remainder of 1, right? I had that additional 1 that I'm not using. That's what a remainder is. And that's what gives you that 4.5. So the reason why that's important is because what I'm going to suggest to you now is when you're working with your variables is you basically think of it that way. Whatever you're to the power of, whatever your index is, you want to think, how can I divide 5 into that index? So essentially you would have, so I'm just going to show you what I mean. So we have square root 25, that's 5. The square root of x to the power of 5. What is the biggest number closest to 5 that is also divisible by 2? 4. So I want x to the power of 4. And what's my remainder to get from that 4 to 5? 1. So I'm going to write this as x to the power of 4 times x to the power of 1. And then you're going to do the same thing for the next one. So y to the power of 3. What's my biggest number closest to 3 that is also divisible by 2? 2. So y3 I will break down as y2 and y1. Seems easy enough with the square roots, I know. You probably think that it's easier to break them into their squareds, but it's when we get into like these fourth roots and stuff that doing it this way will make your life a little easier. Okay, so now I'm going to continue to simplify. I probably shouldn't have taken the square root of 25 yet, but anyway, so 5, then the square root of x to the power of 4. So again, here's where that divisibility thing is going to help you. You will basically do 4, so the exponent underneath, divided by the index number. So what's 4 divided by 2? 2. So this is x to the power of 2 that comes to the outside. Same principle over here. y to the power of 2. We're taking the square root of y to the power of 2. We already know this from previous examples that they cancel each other out, but basically what's happening is you're taking this exponent and dividing by the number in the index. 2 divided by 2 is 1. So we're left with a y1, or just y. And then we're interested in what's left over. So we took the square root of x to the power of 4. We took the square root of y squared. So what's left? I have the square root of x1 that I can't simplify anymore. I hope they see my screen and not my face, because anyway. Okay. Are we good with that? I totally lost my train of thought. Does that make sense? Yeah, okay, cool. Next one. So this time my index is 4, so it means I want to divvy up b to the power of 9 into things that are divisible by 4. So I want b to the 8 times b to the 1. Now, just really quickly, everyone watch for a second. The divisibility thing hopefully should make sense. I hope you know like how to divide evenly and stuff, but if that's confusing you, there is always another way of doing it. It just takes a little longer, where you basically break the number down. It's essentially the same principle, where you break the number down. So you use the index number, and you would say b to the power of 4 times, okay, can I do another full b to the power of 4? Yep, I can. So b to the power of 4, now I'm at 8, all right, and I have 1 left. So you can always break it down into however many of those index numbers you can make until you get to the exponent that's there. So this is 4, 4, that's 8, and then 1. So you can always break it down that way too. It's just, in my opinion, that's a little longer and this is a little easier, but you can always do it that way if this is confusing. Anyway, so again, we have b to the power of 8 times b. 8 divided by 4 is 2. So b squared will come out in front. And then we are left with a 4th root of b underneath the radical. If I had done it this way, I would have had the 4th root of b4, which is b, that would come to the outside. The 4th root of b4, which is b, that would come to the outside. And the 4th root of b left over. B times b is b squared, 4th root b. Okay, so they both give the same answer. It's just 2 different ways of doing the exact same thing. All right, cube root of 48y5. So first of all, we'll start with our cube root of 48. So what is 48 divisible by that is also a cube, perfect cube? Yep. 8n. No,
8 times 6.
8 and 6? Is that what you said? We'll say that's what you said. That's what you said. So 8 times 6. And then we're going to break y to the power of 5 down in a similar way, right? It's the same kind of principle. We're breaking these exponents down into their perfect cubes or perfect squares as well. We just sort of use the index number and remainders to sort of help us do that. So y to the power of 5, how am I going to break down y to the power of 5?
Y power 3 times y squared.
Good. Y to the power of 3 times y squared. Again, so you want divisible, right? So what's the nearest number to 5 that's also divisible by 3? That's 3. And then what's my remainder when I take 3 away from 5? 2. So y to the power of 3 and y to the power of 2. All right, and then again, we break down into the things that we can take the cube root of. So the cube root of 8 is 2. The cube root of y cubed is just y. And then what are we left with under the radical that we couldn't simplify? We couldn't simplify this 6, and we couldn't simplify this y squared. So this is what our final answer would look like. You guys are going to try E and F. I'm going to temporarily stop recording. What? You're just gonna try example E and F. Did you already do it? What? I don't understand what you're saying. Come show me. I'll put my mask on. I won't stop recording yet in case I do make a mistake. You do. The cube root of y cubed is just y. I wrote it. There's a y there. Don't forget to write your 3 in the index. Okay, I'm gonna stop recording, and then I want to check to see if it actually recorded my screen. I know. Okay, stop recording.